So in this video we're just going to look at the Unit 2 SAMS question. Here we have two forces F and G acting on an object such that F is I minus 8J, G is 3I plus 11J, and the object has a mass of 3 kilograms. Calculate the magnitude and direction of the acceleration of the object. So here we have our object, and again, like in the previous video, I'm just going to apply all the forces around the object. So F is 1I minus 8J, so we have 1 in the I direction and minus 8 in the J, so I'll put 8 there. Then G is 3 in the I direction and 11 in the J. So when I come to look at these forces as a whole, the overall force is going to be 4I, 3 plus 1 in the I direction, and we've got 11 minus 8, so that will give us 3J newtons overall acting on this object. So I've effectively just resolved in the horizontal and vertical. So given that now, I can just draw a little triangle of forces. So there's 4 in the I direction, 3 in the J, and I can create my little triangle of forces with resultant as the hypotenuse. I can see again we've got this 3-4 triangle, so Pythagorean triangle. So r squared will equal 3 squared plus 4 squared, and we should get r equaling to the square root of 25 as in one of the previous videos. R is 5 newtons. So the actual force acting on the object is 5 newtons. So what we've got is this object having force of 5 newtons act on it. If we take the angle to the I direction, theta, so tan theta is equal to 3 over 4. So theta is the inverse tan of 3/4, which is 36.87 degrees. Now it asks for the magnitude of the acceleration. So what we've got is we've got this particle which has a mass of 3 kilograms, and it's got a force of 5 newtons acting on it at an angle of 36.87 degrees to the I direction. Well, if we're going to find the acceleration, we just apply F equals ma. The force is 5. That's the only force acting on the particle. Its mass is 3, so an acceleration will denote as a. So 5 divided by 3 must be the acceleration of the particle. So 5/3 ms to the minus 2 is the acceleration of the particle.